You are warmly welcome on SLTV Lab.
Ladies and gentlemen, I give you a warm welcome once again on SLTV Lab. Today I would like us to see cardiac axis deviation. I'm going to make it easy practically. I'm going to show you how to do it. I'm going to show you the direction of depolarization of ventricles. So there is a degree at which we would say it is normal or abnormal. So let's do it practically. Now suppose you have calculated the QRS amplitudes of all limb leads. Let's today see three bipolar limb leads. Let's see lead 1 if it is equals to plus 2, lead 2 equals to minus 1, lead 3 equals to minus 3. You remember, you take the summation of all QRS complex waves. I mean Q wave, R wave, and S wave. The summation of all those three waves. If there are two, you only just do summation of the two waves. But in summary here, we suppose you have found plus 2 on lead 1, minus 1 on lead 2, and minus 3 on lead 3. Now let's see how to do it. So there is a space for read 1, read 2, and read 3. Let's start with read 1. So you draw the line for read 1. So the direction of the read 1 is toward the left, isn't it? You know the flash points toward the left. Now read 2, the flash points downward, and then read 3, the flash points downwards as well. Good. You remember for read 1, the right arm is negative and the left arm is positive. That is why the flash points leftwards. For read 2, the right arm is negative and the left foot is positive. That is why it points downwards. The same read 3, left arm is negative and left foot is positive. That is why it points downward. Good. Now at the center of every line, let's start from lead 1. This is the center, is considered as 0. The same on lead 2, that is 0. Lead 3, that is 0. Good. We have the center of every side. You see, this is the triangle. It is equilateral triangle. Do you get it? Now there is a side for read 1, a side for read 2, a side for read 3, and the center on each side. Now this is the center of the whole triangle. Do you get it? Remember, this is the center for the whole triangle. Now let's go on. Now remember, for read 1 it was just plus 2. Plus 2. Now you see we have drawn the line towards the left. That is plus 2. Read 2, it was minus 1. That is the line for minus 1. So it points upward. Upward, that is negative way. So read 3, we found it was minus 3. It also points upward towards the left arm. So it is negative way. If it was positive, it would point downwards. So good, we have drawn the vector of the QRS amplitude of every read. Let's go. Now the next step, we are going to draw the triangle connecting the end of the three vectors. So this is the triangle. So at this point we have three triangles. The big triangle connecting the reads, and the small triangle connecting this amplitude of the read. I mean the amplitude of QRS of every read. Now, the next step is now to show the center of this small triangle. You get it? We have how many triangles? We have 2 triangles. The triangle for read 1, the big triangle made up of the read 1, read 2, and read 3. And the small triangle made up of the 3 lines connecting the amplitude of QRS of every read. For read 1, remember it was plus 2. Plus 2, as it is positive, the vector points towards the left arm, towards the left. For read 2, it was minus 1. So the vector points upward at the negative side. For read 3, it was minus 3. It's pointed upward. And we have the center for each triangle. The next step, we are going to draw the horizontal line. This is the horizontal line passing through the center of the big triangle. You get it? This is the line passing through the center of the big triangle. Then we are going to draw the line connecting the centers of both small and big triangle. This is the line connecting the centers of both triangles. Now, the degree between, or the angle between these 2 lines, that is the cardiac axis deviation. So, do you see this degree, this angle? This horizontal line, we consider it as 0. Now, can you imagine that line which is up? So we're going negatively. It's around minus 45 degrees. So this is the cardiac axis deviation. So actually, I wanted you to see how it is done. Thank you. Thank you for watching the video. I hope it's very helpful. So please, don't keep this information just with yourself. Share this information to your colleagues. And see you in another video next time. May God bless you abundantly.
Please support this channel by pressing like, subscribe, and the bell. This is a huge support for this channel. May God bless you.